Light, Reflection and Refraction. CBSE Class 10 Science, Chapter 10 Notes. Reflection. Reflection of light. The phenomenon of bouncing back of light into the same medium by the smooth surface is called reflection. Incident light. Light which falls on the surface is called incident light. Reflected light. Light which goes back after reflection is called reflected light. The angle of incidence. The angle between the incident ray and the normal. An angle of reflection. The angle between the reflected ray and the normal. Mirror. The surface that can reflect the light is a mirror. Plane mirror. If the reflecting surface is a plane, then the mirror is plane. Spherical mirror. If the reflecting surface is part of the hollow sphere, then the mirror is a spherical mirror. Parameters of mirror. The spherical mirror is of two types, convex and concave. Convex mirror. In this mirror, reflecting surface is convex. It diverges the light, so it is also called the diverging mirror. Concave mirror. In this mirror, reflecting surface is concave. It converges the light, so it is also called converging mirror. Parameters of mirror. Center of curvature. The center of hollow sphere of which mirror is a part. The radius of a curvature. The radius of hollow sphere of which mirror is a part. Pole. The center of mirror or middle point is pole. Principal axis. The line joining the pole and the center of curvature is called principal axis. Aperture. The size of mirror is called aperture of mirror. Principal focus. The point of the principal axis where all the incident rays parallel to principal axis converge or diverge after reflection through mirror. Focal length. The distance between pole and focus point is called focal length. Special rays for formation of image. A ray of light parallel to the principal axis of a spherical mirror after reflection converges or diverges from focus. A ray of light passing through or appearing from the center of curvature of a spherical mirror is reflected back along the same path. A ray of light passing through or appearing from the focus of a spherical mirror becomes parallel to the principal axis. A ray of light which is incident at the pole of a spherical mirror is reflected back, making same angle with principal axis. Use of concave mirror. It is used as a makeup mirror, the reflector in torches, in headlights of cars and searchlights, doctor's head mirror, solar furnace, etc. Sign conventions of spherical mirror. All the distances are measured from the pole of the mirror as the origin. Distances measured in the direction of incident rays are taken positive. Distances measured opposite to the direction of incident rays are taken as negative. Distances measured upward and perpendicular to the principal axis are taken as positive. Distances measured downward and perpendicular to the principal axis are taken as negative. 1 divided by f is equal to 1 divided by v plus 1 divided by u, where f, v and u are focal length, image distance and object distance. Linear magnification. This is the ratio of the height of the image to the height of the object. M is equal to h colon h, where m is magnification, h is height of image and h colon is height of the object. Use of convex mirror. Convex mirror are used as rear view mirror in vehicles, as shop security mirrors, etc. Refraction. Refraction of light. The bending of light at the interface of two different mediums is called refraction of light. If the velocity of light in medium is more, then medium is called optical rare. Example, air or vacuum is more optical rarer. If the velocity of light in medium is less, then medium is called optical denser. Example, glass is more denser than air. Refractive index. It represents the amount or extent of bending of light when it passes from one medium to another. There are two types of refractive index: relative refractive index and absolute refractive index. Refractive index of medium with respect to other medium is called relative refractive index. Refractive index of medium 1 with respect to medium 2 is equal to speed of light in medium 2, that is V2, divided by speed of light in medium 1, that is V1. Refractive index of medium with respect to air or vacuum is called absolute refractive index. Absolute refractive index of medium M is equal to speed of light in air, that is C, divided by speed of light in medium, that is Vm. Incident ray is an incoming ray on the refracting surface. Refracted ray, it is an outgoing ray from the refracting surface. An angle of incidence I, it is the angle between incident rays and the perpendicular line, that is normal, at the point of incidence. An angle of refraction R, it is the angle between refracted rays and perpendicular line, that is normal, at the point of incidence. Law of refraction. According to this law, the incident ray, refracted ray and normal at the point of incidence all lie in the same plane. The ratio of the sine of angle of incidence to sine of angle of refraction is constant. That is sine I divided by sine R equal to constant mu. Lens. The transparent refracting medium bounded by two surfaces in which at least one surface is curved is called lens. Lenses are mainly two types: convex lens and concave lens. Center of curvature. The center of two spheres of which lens is part is called center of curvature. Radii of curvature. The radii of spheres of which lens is part is called radius of curvature. Principal axis, the line joining the centers of curvature of two surfaces of lens, is called principal axis. Optical center, it is the special point on the principal axis. Light incident on the optical center passes through the lens without deviation. Principal focus, the point on the principal axis at which all incident rays parallel to the principal axis converge or appear to diverge after refraction through the lens. Special rays for image formation by lens. An incident ray parallel to the principal axis after refraction passes through or appears to come from second focus of the lens. An incident ray passing through the optical center of the lens goes undivided from the lens. An incident ray passing through the first principal focus of the lens or directed towards it become parallel to the principal axis after refraction through lens. Use of lens. In photographic cameras, magnifying glass, microscope, telescope and human eye. Light travels in straight line. Light gets reflected when it falls on polished surfaces like mirrors. Light suffers refraction when it travels from one medium to another. There is a change in the wavelengths. Light when it moves from one medium to another. The bouncing back of light when it strikes a smooth or polished surface is called reflection of light. Reflection is of two types: specular or regular and diffuse or irregular reflection. The angle of incidence is equal to angle of reflection. Mathematically, we have angle I equal to angle R. The image is as far behind the mirror as the object is in the front. The image is unmagnified, virtual and erect. The image has right-left reversal. Focal length of a plane mirror is infinity. Power of a plane mirror is 0. If a plane mirror is turned by an angle, the reflected ray turns by 2 pi. The least size of a plane mirror to view an object is equal to half the size of the object. Pole or vertex, the center point of a mirror, is called its pole. Center of curvature. The center of the sphere of which the mirror is a part is called center of curvature and it is denoted by C. Radius of curvature. The radius of the sphere of which the mirror is a part is called radius of curvature and it is denoted by capital R. Principal axis. The straight line passing through the pole and the center of curvature of the mirror is called the principal axis. Principal focus. It is the point on the principal axis at which the rays parallel to the principal axis meet after reflection or seem to come from. For a concave mirror, the focus lies in front of the mirror and for a convex mirror, it lies behind the mirror. In short, a concave mirror has a real focus while a convex mirror has a virtual focus. Focal plane, a plane drawn perpendicular to the principal axis and passing through the principal focus. Focal length. The distance between the pole and the focus is called focal length. It is represented by small f. The focal length is half the radius of curvature. Aperture. The size of the mirror is called its aperture. It is also defined as effective diameter of the light reflecting area of the mirror. Real image. When the rays of light after reflection from a mirror actually meet at a point, then an image formed by these rays is said to be real. Real images can be obtained on a screen. Virtual image. When the rays of light after reflection from a mirror appears to meet at a point, then the image formed by these rays is said to be virtual. Virtual images can't be obtained on a screen. The following rays are used while drawing ray diagrams to find the position of an image. A ray of light is parallel to principal axis after reflection passes through the focus. A ray of light passing through the focus after reflection becomes parallel to the principal axis. A ray of light incident on the center of curvature retraces its path after reflection from the mirror. For mirrors, the following results are whole. U is negative if the object is in front of the mirror, that is a real object. U is positive if the object is behind the mirror, that is virtual object. V is negative if the image is in front of the mirror, that is real image. V is positive if the image is behind the mirror, that is virtual image. Focal length of a concave mirror is taken as negative. Focal length of convex mirror is taken as positive. When the image formed by a spherical mirror is real, it is also inverted and is on the same side of the mirror as the object. Since both V and U are negative, the magnification is negative. Important points. Continue. When the image formed by a spherical mirror is virtual, it is also erect and is on the other side of the mirror as the object. In this case, U is negative and V is positive. Therefore, M is positive. The expression for the mirror formula is 1 divided by U plus 1 divided by V is equal to 1 divided by F. Linear magnification is given by expression. If M is positive, the image is erect with respect to the object, and if M is negative, the image is inverted with respect to the object. The position of the image for various positions of the object for a concave mirror is as shown in this table below. The table is also shows the use of the mirror for different positions of the objects. So let's look at it. If the position of object is between the pole and the principal focus, the position of image will be behind mirror. The nature of image will be virtual, erect and magnified. The uses of such mirror are in shaving mirror and dentist mirror. If the position of the object is at the principal focus, then the position of image will be at infinity. Nature of the image will be extremely magnified, and and the uses will be in torches and headlights. If the position of object will be between focus and the center of curvature, the position of image will be beyond center of curvature. Nature of image will be real, inverted and bigger than object, and it is used in floodlights. If the position of object will be at the center of curvature, then the position of image will be at the center of curvature, and it will be real, inverted and equal to the size of the object. And this type of mirrors are used in reflecting mirror for projector lamps. If the position of object is beyond the center of curvature, the position of image will be between the principal focus and the center of curvature, and it will be real, inverted and diminished. If the position of object will be at infinity, then the position of image will be at principal focus or the focal plane. The nature of image will be real, inverted and extremely diminished in size. The uses will be to collect heat radiation in solar devices. The position of the image for various positions of the object for a convex mirror is as shown in the table below. The table also shows the use of the mirror for different positions of the object. So if the position of the object will be at infinity, then the position of image will appear at the principal focus, and the nature will be virtual, erect and extremely diminished. The uses will be in rear view mirror. If the position of object will be between infinity and the pole, the image will appear between the principal focus and the pole. The nature of the image will be virtual, erect and diminished. The uses are used in rear view mirror. The bending of light when it travels from one medium into another is called refraction of light. N equal to speed of light in vacuum, divided by speed of light in the medium is equal to C divided by V. As light travels from one medium to another, the frequency of light does not change. Light refracts because it has different speeds in different media. The refraction of light obeys the following two laws. Number 1. The incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. Number 2. The ratio of sine of the angle of incidence to the sine of the angle of refraction is constant, and this constant is called the index of refraction or a refractive index. If WNG is the refractive index of glass with respect to water, then ANG be the refractive index of glass with respect to air, and ANW be the refractive index of the water with respect to air. The most familiar and widely used optical devices is lens. A lens is an optical system with two refracting surfaces. The simplest lens has two spherical surfaces close enough together that we can neglect the distance between them. Such lens is called a thin lens. The two common type of lenses are converging lens and convex lens, diverging lens and or concave lens. It should be noted that if the above lenses are surrounded by a material with a refractive index greater than that of the lens, the convex lens gets converted into a concave lens and vice versa. Any lens that is thicker at its center than at its edges is a converging lens with a positive F, and any lens that is thicker at its edges than at the center is a diverging lens with negative F. Optical center. The center point or C is the lens in the lens is called optical center. If a ray is incident towards the optical center, it passes undeviated through the lens. Principal axis. Since the lens contains two spherical surfaces, therefore it has two centers of curvatures. The line joining these centers and passing through the optical center is called the principal axis. Aperture. The effective width of a lens through which refraction takes place is called the aperture. Focus and focal length. If a beam of light moving parallel to the principal axis of a convex lens is incident on it, the rays converge or meet at a point on principal axis. This point F is called the focus. The distance CF is called the focal length. If a beam of light moving parallel to the principal axis is incident on a concave lens, the beam of light diverges. If these diverged rays are produced backwards, they meet at a point F on the principal axis. The transmitted rays appear to come from this point. This point F is called focus and distance CF is called focal length. All rays parallel to the principal axis after refraction pass through the principal focus or seem to come from it. A ray of light passing through the focus after refraction becomes parallel to the principal axis. A ray of light passing through the optical center of the lens after refraction passes undeviated. A convex and a concave lens can be supposed to be made up of prisms. Image formation by concave lens. Position of object is at infinity. Then the position of image appears at principal focus on the same side as that of object, and the image will be virtual, erect and extremely diminished. It is used in spectacles for short-sightedness. If the position of object is between infinity and lens, the image appears between principal focus and the lens. The nature of image will be virtual, erect and diminished. The uses will be spectacles for short-sightedness. Image formation by convex lens. Position of object at infinity, the image at principal focus or in the focal plane. The nature of image will be real, inverted and extremely diminished in size, and the uses in telescopes. If the position of object is beyond 2f, the image will be between f and 2f and will be real, inverted and diminished. The uses in camera and in eye while reading. Position of object at 2f, image will be at 2f, will be real, inverted and equal to the size of the object. Used in photocopiers. If the position of object between f and 2f, the image will be beyond 2f, real, inverted and bigger than object and used in projector microscope objectives. If the position of object is at the principal focus, the position of image will be at infinity and will be real, inverted and extremely magnified, and it is used in spotlights. If the position of object between optical center and the principal focus, the image on the same side as the object and will be virtual, erect and magnified. It is used in magnifying glass, eye lenses, spectacles for short-sightedness. New Cartesian sign conventions. All distances, object distance u, image distance v and focal length f are measured from the optical center. The distances measured in the direction of incident ray are taken as positive and distances measured against the direction of incident ray are taken as negative. All distances or heights of objects and images above principal axis are taken as positive and those below the principal axis are taken as negative. For two lenses, the sign convention take the form u is negative if the object is in the front of lens, u is positive if the object is virtual, v is negative if the image is on the same side as that of object, and it is positive if the image is real. Focal length of convex lens is taken as negative and that of convex lens is taken as positive. Lens formula for convex lens is 1 divided by V minus 1 divided by U equal to 1 divided by F. The linear magnification produced by a lens is defined as the ratio of size of image to the size of object. If the magnification of a lens is negative, then the image form is inverted and real. If the magnification of lens is positive, then the image form is erect and virtual. Power is defined as the reciprocal of the focal length. Power is measured as diopter.